Hello folks! Today we're going to be exploring Plutus and how it serves as a foundation for building decentralized applications on Cardano. I'm Shruti Appiah, Head of Product for Smart Contracts.
Hi, I'm Simon Thompson. I'm Technical Director for the DApp platform for Cardano.
So why don't we give you a bit of an overview of Plutus and really talk about it in the context of the ocean, the island, and the pond. And our colleague, who's the technical lead on Plutus, Peyton Jones, will be giving a short overview of Plutus and how it relates to those contexts.
Hi, I'm Peyton Jones, and I'm the team lead for the Plutus team. For a long time, I had a bit of a difficulty introducing myself and what I do at work. I would say I work on the smart contract support for Cardano, probably, or eventually. And so I'm really looking forward to the fact that now the Alonzo hard fork has happened, and I can finally drop all those qualifiers and say I work on the smart contract support for Cardano for real, which is really nice. And it means this is a good time to talk about Plutus, where we are, and where we're going. And the first thing to say is, well, who is this for? So the kind of subtitle of this conference is The World Comes Together on Cardano. And into, well, does the world come together on Plutus? Probably we should also then say, eventually. Charles likes to talk about this metaphor of the island, the pond, and the ocean, which is this kind of gradually increasing scope where you target a small group of people who you can reach really well and you have good ties to, and where you can actually innovate because you're focused on a much smaller group. Then gradually you expand from there to a pond that has a lot more adjacent people and where you can actually start to deliver more value. And then one day you get to the ocean, you get to the wide seas that really encompass all the stuff that you're actually aiming for. And well, of course, this begs the question of where are we today? And the answer is that we are still firmly in the island. You can't skip the island. And as of today, the Alonzo hard fork has happened. And that means that we actually have the basics on mainnet. But it is still the beginning. It's the end of the beginning, but we are still at the beginning. And that means that for the time being, we are still going to be focusing on the minimum viable product, getting the people who are the best and the best place to work on things going and continue to innovate. And for us, the island, the MVP, is Haskellers. And that's not just because we're a Haskell shop, although, I'm not going to lie, there is part of that in there, but also because it gives us a great tool to innovate in. That's why we use Haskell. We believe it's a good place, a good tool to use to innovate and come up with new things. And finally, this is for the pioneers. When we started using Haskell, when we decided we were going to use it as the basis for our smart contract development, people said, well, but nobody uses Haskell. No one's going to come to your platform. No one's going to want to. And to that, I just have to say, well, look at the attendance on Lars's Plutus Pioneers course, which frankly completely shocks me and is incredible and a really great testament to how passionate people are about Cardano. Some of you all are out there furiously swimming towards the island, even if you weren't on it to begin with, and I salute you for that. This is definitely for you. So, where are we? Alonzo has happened. We've deployed some new, potentially quite transformative technology onto Cardano, but it's raw, right? You know, here we are, we're like at the beginning of the age of computing, where you've got this big dial, this big rack of dials, and you've got to connect things up with wires, and you know, you can see the glimmers of where we're going to be. But you know, at the moment, there's still a lot of dials. Ultimately, this is because the programming language that we've built into Cardano itself at the lowest level is a variant of the Lambda calculus. And here is good old Alonzo Church himself, the namesake of the era, talking about how, you know, maybe if you squint, you could come up with some other use for this technology that he developed other than for logic. But you know, you can sense a certain level of skepticism here, and I'm sure that if he saw what we were doing today, he would be baffled, hopefully in a good way. And this is Plutus Core. Plutus Core is just the Lambda calculus, well, a variant of the Lambda calculus, plus some quite expressive built-in functions. But it's old technology. You know, it's the ancient weapon for an elegant age brought into the blockchain era. But this gets us something. It gets us a functional programming language, a pure functional programming language, no less. It gets us something that's very minimal, easy to reason about, and yet it's also extensible because of the way we've designed its built-in functions and types. We can change it without causing ourselves too much trouble. It's deterministic, and this is something that's really not to be taken for granted. We've gone to a lot of effort to make sure that the whole system is deterministic and won't trip you up in the way that many other blockchain systems today do. And finally, it's verified. Well, nearly. We're working on it. We have Agda implementations of the language, the meta theory, the interpreter, but we're not yet in a situation where we can actually use those for real in the real implementation of Cardano, which, for my money, is the point at which we would be able to stand up proudly and say that we had verified the implementation. I believe that we're going to get there, but it's a long project, even with some of the world experts on verifying programming languages in the team. But I look forward to when I can delete that, another qualifier from my statements. Now, the thing is, no one really wants to write Plutus Core in the same way that no one really wants to write assembly. So I know you're all not in the audience, but imagine you're in the audience. Put your hands up, anybody who's written some assembly. Okay, now keep your hands up if you enjoyed it. Now, actually, I'm expecting that's probably a lot of you because programmers are all masochists. But even if you did, one-off, I think you probably wouldn't want to do it as your day job. And that's why we went looking for a better source language. And we found Haskell. And this is actually slightly a lie because, in fact, part of the reason we designed Plutus Core the way we did was so that it would be a nice target language for Haskell. But this has worked out really well, and a lot of the work that we've done has gone into this translation. As a result, we get a lot of goodies for free. We get Haskell's rich and expressive surface syntax, support for all the things that Haskell, well, almost all the things that Haskell supports for free, and even the tooling for Haskell works as well. And that's a lot of work that we didn't have to do, re-implementing all of that. And on top of that, we can start to build other things. We have projects such as Milo, which is a domain-specific language for writing financial contracts, which you can hear much more about in other talks at this summit. We hope that we'll be able to build other systems on top of this, such as Mune's Glow language, and maybe we'll even have other languages that compile directly to Plutus Core in the future. There's a lot of avenues open. But today, almost all of that is outside the island. We are still focusing on the island. That's where we are today, and that's where we're going to be for a while. And for us, that means Haskell and some tools built upon Haskell. And if we take those together, that gives us, well, a foundation that we can build on. We've got pieces that we can actually start to use to make software that people actually want, that does something that people care about, that's not just, us writing nice white papers about how brilliant our systems are, but actually provides some value to the world. And we call this Plutus Foundation. But once you get beyond that, you start to realize that it's a really complicated life building a Plutus application or a distributed application. It's not at all easy, even once you deal with the blockchain parts. Plutus applications are fundamentally distributed systems, and we all know how complicated those are. It is the topic du jour for about the last few decades, and all that complexity doesn't necessarily go away just because you're using a blockchain. If nothing else, multiple parties have to communicate via the internet, and then they have to talk to Cardano, which is actually not the simplest thing to interact with, even if all you're doing is submitting transactions. And the real information and action flow in a distributed application is tremendously complicated. It requires multiple parties to communicate, to monitor the blockchain state, to deal with network issues, failures, rollbacks, all of these kinds of things. It's really not that easy. And that's why, as we started trying to do this ourselves, we realized there's really quite a lot of things you need to deal with. And to help with that, we have developed for ourselves and for you, because we are also users of this system, what we call the Plutus Application Framework, which is a set of libraries designed to shield your application from the horrible world of reality and manage some of these issues for you. And this then gives us a slightly taller platform to build from. And we hope that that will help a lot more people build the future, whatever that might look like, on top of both Plutus Foundation and the application framework. But we're not the only people building. We know that all of you out there are tremendously talented, passionate developers who will no doubt take what we've done and improve upon it or replace it. We thoroughly expect that there will be many people providing the key infrastructure that people need to really develop applications easily on top, or maybe even substituting for some of what we've done. A bit of healthy competition is absolutely a good thing. If you can show us how to do it better, go for it. We will be delighted to hear about it and help. And so that's where we are today. We've got the platform on which to build, and now it's a case of continuing to improve the platform and actually building things on top of it. And that's all from me. Thank you very much for listening. And I'm now going to hand you over to my colleagues who will talk a bit more about what's coming next.
So you've had that very good overview from Michael. And I think what's clear from that is that, just as Michael introduced with his drawing of the owl, this is the end of the beginning, but it's not the end of the whole Plutus project. I mean, what we've done is Plutus is now available on through the Alonso hard fork, is available on the Cardano blockchain, but there's a lot of other things that need to be developed, not least whole distributed applications. It's a long step from having Plutus on-chain to building complex, scalable, robust distributed applications. It's a difficult area, but what we have in Plutus is a secure foundation for doing that. I think that's a great starting point, and we've got a platform on which to build very successful distributed applications. So I think that's my feeling about where we're at the moment.
Yeah, I do agree with you on that. I do think that if you want to have a flourishing ecosystem of many different dApps, then you do need that kind of a strong foundation, and that foundational layer is enabled by our smart contract language, which is functional. So there is a lot of advantages to that as well. But yeah, we do require quite a bit of critical infrastructure as well to support all of these applications, and those critical infrastructure pertain to everything from developer tools all the way to usability tools, right? Just by having the raw technology, you aren't able to make things usable. So that's also something to really keep in mind. So usability tools such as we need wallets, light wallets as well. We need identity solutions. We need solutions for economic identity such as Milo. And all of those types of more user-centric applications as well will really help to take this to the next step and actually bring something that's so deeply technical to the rest of the world to enable accessibility to anybody that doesn't even have familiarity with the blockchain.
But I think a message we're going to come to right at the end, but I think it's worth saying now, is that it's not just up to IO to do that. We can see there's a burgeoning community of developers, companies, individual developers who are building apps on top of Plutus, or apps that will work with Plutus. So we see that it's not simply an IO thing, but it's a whole community growing up, and we welcome that collaboration and contribution that's coming from lots of people out there. So that's something that's really special. Yeah, we do think that open source development is quite important, especially in this area. We are building decentralized technology here, so the development should also be likewise decentralized. So we're expecting to see a lot more open source contributions moving forward, and we are gearing up for that within our organization as well, by providing as much documentation that we can to support all of these different foundational pieces, and by following that documentation, different members of the community and different companies within the ecosystem are also able to contribute in a productive manner. So I think that as it pertains to that, technical documentation is quite important, but also we need to foster community development in different ways. So for example, we do have several means of doing that, such as Catalyst and so on. But before we talk about more of those high-level stuffs, let's dive a little bit into Plutus, Simon, and really talk about the language itself and how it's been designed, some of the trade-offs that it might have, but also some of the advantages that come along with the design of the programming language itself. Okay, yeah, so I think one of the key things is that Plutus has been built on a functional programming basis rather than imperative programming. So that means that if we do have state, it's explicit, and we're in a situation where it's much easier to reason about the behaviour of programs. And I think that underlies perhaps something we see happening in certification. We're thinking about certifying apps on Plutus in different ways. And certainly ultimately we can see the highest level of certification being one where we do formal proof of correctness
of smart contracts. And that's something which is facilitated by writing in a functional style. But actually closer in on the development roadmap, and something that's there already, is work from QVIC, who are the experts on property-based testing for automatically establishing properties of smart contracts. And they are prototyping, being announced at this summit, prototyping, building a framework in which contract developers can ensure that contracts they write have particular properties, such as it always being possible for participants to get money back from inside a contract. So you'll hear more about that in other sessions, but that's something that's made a ton easier by working in a functional framework rather than an imperative one. So I think that's a really important message.
Definitely. I think that even as it pertains to validating and verifying if certain cryptoeconomic behaviors are present in the system, or if the incentive systems within the system will actually lead to certain types of system goals, that is also typically within the field of cryptoeconomics, which is something that I'm deeply passionate about and also familiar with. They are all expressed in mathematical statements, right? And having the program itself be very akin to that allows for a much more straightforward way of doing that validation of behaviors, as well as ensuring that certain types of checks and formal verification is very straightforward to do. All right. The other aspect of this is also the fact that there's no notion of global state. Instead, there are several concurrent local states, and that is enabled by the extended UTXO model, which some of you also might be familiar with. But Simon, could you also perhaps touch on the extended UTXO model and how that operates?
Sure. I mean, this isn't a place to go into lots of detail, but EUTXO is based on extending the Bitcoin model, where the crucial thing on the blockchain are unspent transactions, and that's what Cardano has, except that there's an extension of that model so that some data can flow with a UTXO. So there's some, and you can think of that as a piece of state that's flowing alongside the UTXO as it's spent. And so different UTXOs carry different states, and those can be thought of as entirely separate. Conceptually they're separate, but almost physically they're separate. They're different UTXOs carrying different pieces of state. And those we can think of those concurrently, and that allows for certain ways of thinking about scaling what's going on Cardano. And I think another crucial thing that we get, as opposed to Ethereum, when a transaction is submitted to the Ethereum blockchain, that operates on the global state. And if two transactions are in contention for performing an action, you can't be sure what the effect of the second one will be before or after the first. So how a transaction will behave depends on the order in which they're processed, and also the cost of a transaction depends on the order in which they're processed. And so until the transaction is submitted, you can't be sure how much it's going to cost to include that transaction on the blockchain. And so that means that you always run the risk of transactions failing to validate because there's not enough gas to pay for them. That can't happen on Cardano. Once you know how much a transaction is going to cost to submit, that's the cost. It doesn't change. So we have what we call determinism there. It means you don't have to pay more than you thought you'd have to pay. And also, if there is contention and two transactions are wanting to spend the same UTXO, if your transaction doesn't get to spend that UTXO, you don't pay any fees. So again, we've got this certainty where other chains, other models don't allow us to do that. So I think we have that fundamental layer of security there, which we're not getting on other chains. I think it's important to realise that. We don't want to oversell it, but it's important to realise that's a fundamental difference.
Yeah, certainly. And I do think that it also presents a different design paradigm altogether, right? The fact that it is based on a UTXO model, as well as the fact that it is deterministic, it presents advantages, but there is also challenges, which is that you cannot directly import over your for example, your DEX design from Ethereum over to Cardano in the simplest case, because of the fact that the design paradigm itself is so fundamentally different. So there is a different way in which you would probably have to architect and design your application in order to suit this account-based model, rather than doing it by just direct means, which is quite common in other ecosystems. But anyway, there are certain other areas that we would also like to touch on, particularly. I know that typically when you want to issue a token, you might have to do that through a smart contract. But in Cardano, we have something called native tokens, which are already built in, so you wouldn't have to have an associated smart contract with it. Could you elaborate a little bit more on native tokens?
Okay, yeah. So on Ethereum, there's this ERC20, which is a contract that allows you to transact with native tokens. But because it's a smart contract, every time you spend a native token, you pay some transaction fees. That's not the case in Cardano. The tokens are built into the foundation of the blockchain, and so you might pay to mint some coins, but you don't pay to transact. Don't pay to make the transaction using those tokens. So you have the advantage there of payment, but also I think a crucial advantage, sort of software engineering advantage. Think about what's happening on Ethereum. You have a contract. You take that contract, you modify it in some way, and then you use it. So your model is, I've got this contract and I know it works. I'm going to modify it in some ways and hope it still works after the modifications. That's not terribly secure. Whereas using built-in tokens, you know that they are properly programmed, and therefore you're not going to introduce by accident or by design any flaws into that. So we're getting that advantage of Cardano. But I think just going back to what Shruti was saying about challenges, I think it's true that not every account-based contract carries over directly to a UTXO-based contract, but a number of people in the community we're seeing are building innovative solutions to meet that challenge. SundaySwap, for example, are looking at DEX solutions, and we see this is an opportunity as well as a challenge. It's an opportunity to think of new models that fit this local versus global state and allow, for instance, larger transactions to be built by third parties who accumulate those transactions on behalf of other participants, new models to build on top of this fundamental foundation. And I think, again, the message, going back to the message, it's the end of the beginning. We're now at a point where that foundation is there, and it's a time for the community to step up alongside what IOHK is doing itself to build effective solutions here.
Absolutely. And we do see this as it's a challenge, but it's a challenge that the community is already rising up to. So you'll see a lot of good work that's done by several different pioneers as well as Plutus partners within the ecosystem. So I believe SundaySwap has written a paper on how to deal with the whole UTXO design pattern, so that's something to check out. And certainly the other advantage of batching multiple transactions into one, as long as they're independent, is certainly a good benefit. So you're able to actually make really big transactions that are composed of multiple smaller transactions within it, as long as those individual transactions are independent of each other and their states are independent, their starting and end states are independent. So those are some of the advantages, and certainly the challenges do exist, but quite a few of the community members are rising up to the challenge of figuring out clever solutions to it and really utilizing the advantages and the benefits of having this type of a system in order to build their smart contracts and compose different DApps that operate quite differently from other ecosystems. So we are very excited to see what's going to come up in the future. And this is truly a platform that's we are provided, but it is evolving, and eventually we want to engineer ourselves out of it and have the community take over a lot more of a decentralized aspect to developing the entire foundational pieces of the ecosystem. So more will come as time goes on, and we do expect moving forward to see a lot more developer activity. We expect that to accelerate really quite a lot. And so far, we've actually already seen quite a bit of DApps that are being built or started to even being tested on the testnet. And as of the hard fork yesterday, actually, cut. I made a wrong temporal reference. Sorry. As of the hard fork that just happened recently, we are also going to be seeing quite a few of these DApps come onto mainnet and be deployed therein. So that's something that makes me quite optimistic, and I'm very excited to see what's to come.
Okay, but just before we conclude, what I'd like to do is just show a few slides that run through perhaps what's going on under the hood a bit for the Milo Run application, which is the client-facing part of the Milo product suite, and that will show some of the components of the Plutus platform that Michael talked about in a bit more detail.
Yeah, Milo Run is an exemplar of a Plutus DApp. It's actually the first Plutus DApp, and so the infrastructure and the architecture that Milo Run uses will very clearly demonstrate how Plutus applications can be built. So you can use that as a reference point as well.
But other models are available. But anyway, let's look at those slides. Okay, what I'd like to do here is run through a few slides that explain how we made Milo Run. Milo Run is the client application for Milo. Contract execution takes place in Milo Run when somebody wants to run a contract on the Cardano blockchain. And the way this works is that Milo Run off-chain produces the transactions that make the contract happen and submits those to the blockchain. It also has to observe transactions on the blockchain to see what other contract participants have done to make the contract progress. So we've got this two-way process of communication. Transactions are submitted, but also we observe other transactions having been submitted. And at the same time, in the app, we're computing progress of the Milo contract. We have to work out off-chain where we should be going so we can build the transactions and update our state of where we are based on the transactions we observe. We also have inputs coming in from users, and we have to interact with wallets to sign transactions. So this is at a high level, this is what's going on in Milo Run. It has to interact with users and wallets. It has to submit and observe the blockchain, and also do computation itself to advance the state. Now, looking a bit inside that model, these are the components that we see being used. On the client side, we've got Milo Run running in a browser, and we have a wallet. That might be a light wallet or a full node wallet such as Daedalus. But irrespective of that, we need to communicate with other things that sit chain side, as it were. We have the Plutus application backend, which allows us to communicate with the wallet backend and also with things like the chain index and DB sync that collect information about what's going on the chain. And we put those components together to give us the workflows that we want to implement. So let's take a look at what happens when we submit a transaction. We submit partial information about that transaction to the PAB, and that then passes information to the wallet backend, which can build a transaction, selecting UTXOs and so on to make up that transaction, passes that back to the PAB, which also generates a URL that is then passed via Milo Run to a wallet to authorize that transaction. And once authorized, that can be submitted to the blockchain. So we have PAB, we have wallet backend, we have a wallet like Daedalus or Yoroi, and finally, once that transaction has been submitted to the blockchain, information about that is incorporated into the chain index potentially, or into DB sync. But those records of what's on the chain get updated with what's been put onto the blockchain. So that's the process of submitting a transaction. Conversely, if we want to observe a transaction, well, its information about it will go into chain index or DB sync, and from there, in fact in this case it is from DB sync, we can observe that in the PAB and pass information about that across to Milo Run. So again, you're seeing these separate components working together, and that information allows us to update. If we are Alice, and there's also a participant Bob in the contract, we see that Bob has submitted a transaction, and that advances the state of the contract, the Milo contract, and we see Alice sees that in her browser, and then perhaps it's her turn to do something, and show that's now the point where she can help advance the contract. So that's it in a nutshell. We've seen the various components, we've seen how information flows between an application and the blockchain, application and wallets, but also we've seen in a bit more detail how those components all fit together. Well, let's get back from the slides. You can see now, you've seen now in a bit more detail how the various components are used to support the sort of workflows you see in a DApp. I mean, I guess that's really what we wanted to say. Perhaps what we wanted to conclude on is just how excited we are at how many people are getting involved with Plutus. We've seen 2 rounds of the Plutus Pioneers program. People are already on the waiting list for a 3rd round of that. And a lot of interesting applications have come out of that. We're seeing applications coming from the community. We're seeing applications coming from the Plutus Partners program. We're seeing applications coming from Catalyst. So a number across the ecosystem, we're seeing people using Plutus to develop effective solutions. There will be more. I'm sure Plutus will evolve. I'm sure the components that support Plutus will evolve and develop, partly through what IO has done and also through what you, the community, have done. So I think we're at the start of a very exciting journey.
Absolutely, yeah. And then certainly this is the start, so we do need to be very cognizant of building out those infrastructural components. And so while Plutus forms the foundation, the critical infrastructure components that sit on top of them and enable for easier development and easier use as well for end users, those are also extremely critical. So let's not forget about those, right? We are encouraging the community to build more of those alongside the other decentralized applications that are more end user facing that they may choose. But it is crucial that we have quite a bit of those critical infrastructure components as well, and we'll be seeing more of that come about as people realize the need for them. Anyway, yeah, this is very exciting times. So I hope you tune into more of the talks that are coming up. I hope that this has proved to be a good learning experience.
Good, and same from me, and do tune in particularly to talks from some of the Plutus partners. See what they've been doing, what they've been developing, the ideas they've got about how to build things on Plutus. Thanks very much.
Thank you.